Hi, guys. Okay.
Oh my god, wait. This is the English.
Now they know.
Last time
Okay.
Silva used to go around the room taking pictures of us for all the projects we did.
I know, and it came out to...
What?
I did, but this year we can't do projects because we're socially distanced.
Really good.
Okay.
At the end of the year, she made a slideshow.
It was cute.
And I liked the pictures.
Yeah.
Yeah, it kind of sucks.
Yeah. I can't even take pictures. I mean, you have masks on. Okay, so we're going to write down a postulate or a theorem for each situation. So, QA equals QA is the reflexive property. Of equality. Because it has an equal sign and not a congruence sign, that's why we put of equality. The next one, it says AB is congruent to BC and BC is congruent to CE. Then AB must be congruent to CE. That is transitive property of congruence. And if Q is between PR, if Q is between PR, then PR equals PQ plus QR. That is the new one that we saw today, segment addition postulate. Then number 4, if AB plus BC equals EF plus FG and AB plus BC equals AC, did I lose you yet? Then EF plus FG equals AC. What they did here was, since this is equal to AC, they took AC and plugged it in here. So then AC equals EF plus FG, and that is substitution. Okay, so now we're getting into the proofs. They set it up for us, which is nice, in the two columns with statements and reasons. They filled in some of the blanks, and we're going to continue filling it in. Before we get to the actual proof part, let's look at what they told us. They said that SU is congruent to LR, and they also said that TU is congruent to LN, and they want us to prove that ST is congruent to NR. So, whoa, it's got blurry all of a sudden. I don't know. There it goes. Okay, so first things first, you take your given and you write it down here, which they did, and then title it given. So if you have no idea what to do, at least get the given part right. Then from there, it says definition of congruent segments. So if they're congruent, then the length of SU is equal to LR, and the length of TU is equal to LN. Now, the next statement, it says SU is equal to ST plus TU. That's segment addition postulate. And same with LR is equal to LN plus NR. Segment addition postulate.
Wait. What is it?
Segment addition postulate. Okay, here's where it gets kind of weird, but I'll show you what they're doing. Since SU equals LR and SU equals this, and LR equals this, they're plugging it into this to make this statement. So they're substituting this for that and this for that. So the reason is substitution. Then for E, they repeat this whole thing again, but the one difference is they replaced LN for TU. And the reason why is TU equals LN, so they put this here. So again, substitution. And again, when you're answering problems on this, you aren't like pulling these words out of thin air. It's like an answer bank. You're dragging and dropping. Then for F, it shows them subtracting LN from both sides. So that's subtraction property of equality. And Then they simplify this. Ln minus ln is just 0. It goes away to leave st. And then here, ln minus ln just leaves nr by itself. And now we're getting to the end because this is matching the prove statement. Then turn it into a congruent statement using the definition of congruent segments. And you're done. The next one is easier and shorter. Number 6. It's saying, given AB is congruent to CD, prove that CD is congruent to AB. Well, we can do that using the symmetric property, and that's what we're going to do. We're just going to use the proof format. So the given, we're just copying this right here. Then AB is equal to CD, that's definition of congruent segments. Then they switch it to CD equals AB, that's the symmetric property. And then turn it back into a congruent statement. We are going to do the one on the back because it's very similar to one of the ones that you'll see on your homework. Okay. So, first things first, let's look at what they told us in relation to the picture. They're saying AB is congruent to DE. Okay. B is a midpoint of AC. That means this side would be the same as this side. And E is a midpoint of DF. That means that would be the same as that. We have to prove that BC is congruent to EF using the proof process. So first things first, we need to copy this here for the given. So AB is congruent to DE. B is the midpoint of AC, and E is the midpoint of DF. It's the clock, I don't know. It makes random noises, I don't know. Okay, and then it says AB is equal to DE. That's because of definition of congruent segments. So the same situations will start repeating themselves. So the more you practice it, the easier it gets. Then C, it says definition of midpoint here. Well, because B is the midpoint, that means AB is equal to BC. And because E is the midpoint, that was a given, DE must equal EF. Then here, it shows BC is equal to DE. Well, here it shows DE equal to AB. Since AB equals BC, you can plug in BC for AB here. And that's how they got this. Do you follow that? Okay, it's substitution. Then they repeated this, but they changed this to EF. The reason why is because DE equals EF, so they plugged that in there. And substitution again. And now we're getting toward the end because it's wanting us to prove that BC is congruent to EF, and we're almost there. We just need to turn it into a congruent statement. BC is congruent to EF. Definition of congruent segments. Okay, so that was that. I'm gonna end this.